Here's a little bit about finding function transformations. And I have two things to worry about. I have to worry about how it's moved, how it's moved to the left and right or up and down. And then I also have to worry about whether it has been stretched or compressed. And so there's a way to check each one of them. I'll do 75 first. This one is a parabola. It's upside down, so I know it's got an a, but it's negative. The term in front is negative. So y equals x squared is the parent function. This is going to be some kind of y equals negative x squared. But I don't know negative ax squared, actually. I don't know what that a is. But I'm going to find out what it is by looking at some values. But I can tell where this one has been shifted. The original vertex of a parabola is at 0, 0. So this one's gone 2 to the left and 3 up. So the horizontal shift is opposite sign. So if it's 2 to the left, it's plus 2. 2 to the left is minus 2 on the graph, but it's plus 2 in the shift. So this is y equals, I don't know what that a is, x plus 2 squared, because now I've shifted the vertex 2 to the left, and then plus 3. Now I can look for a point, a nice solid point to find out what that a is. And I'm going to try to use points that are exact integers. And here's a nice one right here. It looks like it's negative 3, 1. That's a nice even point, so I don't have to deal with fractions. So I have negative 3, 1 is a point, and I can plug that in for x and y. 1 equals a, that's what I want to find out, what that shift value is. Negative 3 plus 2 squared plus 3. Negative 3 plus 2 is negative 1. Negative 1 squared is 1. So 1 equals 1a, or just a, plus 3. Now I'll subtract 3 from both sides. Negative 2 equals a. So I know this function is y equals negative 2. What was the shift again? X plus 2 squared plus 3. And if you want to prove it, we can look at Desmos. We can do negative, what was it? Negative 2 times x plus 2 squared plus 3. And you can see there's the function. And let me just look approximately where it crosses the x-axis to see if that works. I've got negative 7.7, and then this is negative 3.22. And let me look at the graph. Yeah, that looks pretty good. Negative 7.7, negative 3.22, where it crosses the x. So that's it. That's the transformation. So moving the vertex of the parabola gets me the plus or minus. If it moves to the left, it's plus. If it moves to the right, it's minus. Whatever that value is in with x. Up and down gets me this value. And then I put in a point, an integer, a very clear point. I could have used negative 3, 1, or I could have used negative 1, 1. That one would have been even easier to use on that graph to try to figure out what the a is. So this is the answer to that one, negative 2x plus 2 squared plus 3. Now this one, the same thing. I know that usually this is y equals absolute value x is the parent function. I know that. I'm trying to see if I'm recording here. I am. I just wanted to make sure. I know that usually the vertex of the absolute value function is at 0, 0, so I've shifted this one 2 to the right and 1 up. So this is going to be y equals, there may be some kind of a stretch, x minus 2, because it's shifted to the right, its opposite sign, plus 1. Up and down shifts with the sign. Up is plus, down is minus, left and right, right is minus, left is plus. So now I've got to figure out what that a is, and to do that, I will use a point. Well, I could either use this one, it looks like 5, 2. That would be a good point to use. Or I could use this one, which might be even easier to use, negative 1, 2. I'm going to use that point, negative 1, 2. So I know I'm using a point negative 1, 2, and I'll plug that in. Y is 2 equals a times negative 1 minus 2 plus 1. Negative 1 minus 2 is minus 3. 2 equals a times absolute value of minus 3 plus 1. Absolute value of minus 3 is 3. 2 equals 3a plus 1. Subtract 1 from both sides. 2 minus 1 is 1 equals 3a. And I divide both sides by 3. 1/3 equals a. So I found my a by using integer points. So I go y equals 1/3. And then inside the absolute value is x minus 2 plus 1. And let me put that into Desmos just to double check it. What was it again? 1/3. I have no short-term memory. X minus 2 and then plus 1. And let me just check it if I've got the right points here. The vertex is in the right point. Where does it cross the y-axis? It looks like, oh man, let me get to that exactly. 0, 1.6667. Yeah, that looks pretty good. So I've got the function. And again, I use the shift of the vertex with a cube, x cubed. If the parent function is y equals x cubed, I look for where that inflection point is. And I use that as the place that I see the shift. And then I find a very good integer point where the x and y values are integers. Plug that back into the equation and then solve it and find the a, whatever the factor is for the stretch or compression. So this one, the parabola here is 1/3, absolute value x minus 2 plus 1. And again, not the parabola, the absolute value, the parabola, 1 was negative 2 times x plus 2 squared plus 3.